Hello guys, I just designed this tiny anti-spark switch and I want to share more about it. So what we have here is input voltage and it will just spit out the output from the out plus and out minus. We have a 125 volt 7 amps fuse here on the output side, and we have enable pin. All of the components are actually, except for the fuse, they are rated for 150 volts DC. Each of the MOSFET is rated for 20 amps and doubled it up for about 40 amps. So there's plenty of room and we are actually limited by the fuse itself. Let me explain why did I design this, where it might be useful. So I just recently bought an e-bike. Let me give you a demonstration. So let's say this is the motor controller of the e-bike and this is our battery. So their connection in between is by the stick cable, which is just from the battery goes directly to the controller. And the controller either has a key switch or a button switch like that, so you can turn it on and off. But if you want to try to add some DC-DC converter, something like this, well, this system doesn't help us because we need to connect the input side of the DC-DC converter directly to the battery so we can actually convert some voltage. And what happens is when I turn off my controller, this one won't turn off. I need to somehow automate the whole system. When I turn this off, I need to be able to turn this off as well. And this is where this part comes into play. So let me give you a demonstration. If I just simply connect just a rocker switch or some kind of a switch on the input side directly to the battery and see what happens. So let me get all of these things to the side, which are not necessary at the moment. So what we have here is 50 volts of DC voltage to simulate our battery. This is the light output to show the output of the DC-DC converter. And this is the input side. And this is live, by the way, so we are actually supplying 50 volts to it. So I'm just going to connect the ground first. And this is going to happen if we connect directly a switch to it. So let me show it. I'm not sure if the sparks are visible, but there's quite a bit of sparks coming out when I first connect it. So this is going to happen if I just connect the switch to it. It will slowly kill the electronics and the switch, which is not good. Also, it is a manual process. I want to automate the whole system. I don't want to deal with another switch. So let me take this off and solder all of the necessary cables and prepare the setup for a demonstration and show you how it works. So the connections are very straightforward. You have the inside. This is going to directly connect to the battery. Let's assume this is your battery. This is plus, minus. And then for the output side, you have out minus, out plus. This goes directly to your DC-DC converter or any device that you want to control. And remember, whatever voltage you are feeding from the input, it is going to be the same on the output side. The trick here is we have the enable cable, enable line, and this does not carry any kind of load. It can be as thin as possible. We need to connect this somewhere we can have a signal that we get only after turning on and off the controller. Let's say in this example, this switch turns on and off this controller, yeah? So if we look at it carefully, we have 5 volt outputs in many of the connectors. So if I can connect this enable pin to one of the 5 volts, it will send us, when I turn this one on, this will provide me 5 volts. And this 5 volt will feed the enable pin and it will activate the whole system. But there's a voltage selector behind it. So if you bridge the middle pad to the 5 volt, you have to provide up to something like 15 volts max. But if you want to provide up to 125 volts, then you have to bridge from the middle one to the plus 20 voltage sign. So at the moment it is currently set for plus 20. That's why I'm going to bridge it to the input side. But you can do it with a controller. This one provides 5 volts. It starts to work from 2.5 volts up to 15 volts if you bridge it to the left side. So, but at the moment it is set for plus 20 volts, so I'm going to bridge it to the in plus. So let me demonstrate it. So this is here again our 50 volts voltage supply. This is the light. So this is light, by the way. At the moment there is a voltage on the output of the regulator, so I'm just going to connect the minus first. The last time we tried to hook it up, it started to give us sparks, so let's try it now. As you can see, no sparks, no nothing, because our enable pin is floating. It is actually pulled down by a resistor, so it is turned off. It does not pull any kind of electric. That is why it is not sparking. So we can safely connect it. So now we have a connection. So as you can see, nothing is turning on. There's no voltage here. There's a voltage on here, but this enable pin prevents any voltage from flowing from input side to the output side. But if let me get the cable open. Okay. So this is the enable pin. I'm just going to touch it to the plus 50 volts and let's see if it's going to turn on. Just let me do it from here. Yep, it just turns on and there are no sparks. Let me show you closely. It's because the current that we are pulling is just minuscule and it's nothing. That's why it's not sparking. There's no nothing. It's completely safe. So that's how it works. And as I said, as soon as I connect it to somewhere that turns on after I turn on the switch, let's say this is the 5 volt. So I have a connection directly to the battery here, from here to here, and from here to here. And I have only one switch. So when I turn this on, the 5 volt is gonna start supplying. And if I connect this to enable pin to 5 volt, one of the 5 volt, or even 3.3 volts, it's just going to work. So yeah, that's it.